My name is Sri Shanti Chalaya, going to handle video lecture on A to D converter using op-amp. A to D converters translate continuous analog signals into discrete digital data for processing. The main types of A to D converters using op-amp are flash type, successive approximation, counter type, delta sigma, and dual slope single slope A to D converters. A to D converters converts continuous analog signals into digital values for processing by digital system. It interfaces real-world signals with processors, and it is basically applied in data acquisition systems. The basic ADC process includes the following steps, which is sampling, quantization, encoding, and the final stage, how to generate the digital output. It translates continuous real-world physical signals like sound or temperature into discrete digital data, ones and zeros that computers can process. It does this through three core steps: sampling, quantization, and encoding. What is meant by sampling? The ADC takes snapshots of the analog signal at regular, extremely fast intervals. The speed of this process is called the sampling rate, which is measured in samples per second. According to the Nyquist theorem, an ADC must sample a signal at least twice its maximum frequency to accurately recreate the signal. The next step is quantization. An analog signal can have a infinite number of values, but computer's memory is finite. So the quantization maps each sampled voltage to the nearest available discrete value on a predefined scale. The scale's range depends on the ADC's bit resolution, which is 8-bit ADC has 2 power 8 is equal to 256 possible values, while a 12-bit ADC has 2 power 12 4096 values. The next step is the encoding process. Once the signal has been mapped to a specific quantized level, the ADC translates that level into a binary number which is in string of zeros and ones. This binary stream is then sent directly to the microcontroller or digital signal processor to give the equivalent digital output. Hashtag ADC is discussed as slide. It is the fastest ADC structure using parallel comparators. It uses a large bank of comparators connected in parallel, each with a slightly different reference voltage to instantly match the analog input across a resistor ladder. It is the fastest method to convert analog signal into equivalent digital output. A stable reference voltage is applied across the resistor ladder. The analog input signal is the output of every single comparator at the same time. Each comparator checks if the input voltage is higher or lesser than its specific reference. Flashlight circuit description is given in this slide. It converts continuous analog signals into digital binary data in a single clock by simultaneously comparing the input voltage against multiple reference voltages. A flash ADC has three parts for the n-bit conversion. First is the resistor ladder setup. A series of 2 power n resistors connected in a row. It steps down the reference voltage to create 2 power n minus 1 unique sequential reference level. Then the series of parallel comparators is used. 2 power n minus 1 operational amplifiers act as the comparator. One input of each comparator is tied to the analog input signal. The other is tied to the specific reference voltage from the resistor ladder. The next is the priority encoder. The digital logic circuit that translates the outputs of all comparators into standard binary code is done by the priority encoder. The resistor ladder divides the total reference voltage. For example, if it is a 3-bit A to D converter, it divides into 2 power 3 steps, which is 8 even steps. In a 3-bit ADC, the reference voltage for the comparators are set at the intervals of 1 by 8 V reference, 2 by 8 V reference, up to 7 by 8 V reference. Simultaneous comparison is done by feeding the analog input signal into all comparators at the same time. Thus, it performs the parallel operation. If the analog input voltage is higher than the comparator's reference voltage, the output is 1. If it is lower, the output is 0. Because the references are ordered, the output always looks like a mercury thermometer, the sequence of ones at the bottom followed by zeros at the top. So now the output of the comparator is given to a encoder, priority encoder, 3 to 8 encoder, which outputs the corresponding final binary value. For example, if it is a 3-bit, it ranges from 000 to 111 depending on the output of the analog voltage, which lies between 0 to 7 by 8 of V reference. Next is the successive approximation A to D converter. It is a highly popular type of A to D converter. It converts the continuous analog voltage into discrete digital code using a successive approximation register and a DAC. The analog input compares the with the internally generated reference voltage. It tests one bit at a time, starting from the most significant bit to the least significant bit. Initially, it is set as 1000, and according to the reference voltage compared with the analog input, the output of the comparator will set the equivalent digital output every time. After n clock cycle, the output of the successive approximation register is taken and which represents the equivalent digital output for an input analog voltage. Now we will see truth table to find the equivalent digital output for the analog voltage. Initially, the digital data is set as 1000. The MSB alone is set as 1 and remaining bits are set as 0. If the equivalent analog voltage is greater than the digital data 100, then the next bit MSB is stayed in 1 and the next LSB is given 1 unless will be 0. On the other hand, if the analog voltage is less than the digital data, then it will be the MSB is made 0 and the next LSB is made as 1. Thus, this is repeated for all 4 bits to find the equivalent digital output for the analog input voltage. If it is a 4-bit word, you need at least 4 clock cycles to find the equivalent digital output. Now discussing the advantages and disadvantages of flash type A to D converter. The advantage is that it has unmatched speed since it is a parallel operation. It can process signals in a single clock pulse, which is ideal for high frequency video, radar, and oscilloscope. Disadvantage is that hardware complexity is more in this case. An 8-bit converter requires 255 comparators, which consume significant physical space and power, and hardware complexity is more, which requires more number of accurate resistor values. Owing to this feature, it is the basic applications of your A to D converter, flash type A to D converter is in design of embedded systems, IoT devices, medical instruments, communication systems, industrial automation. Thus, we have discussed 2 types, flash type and successive approximation. Flash type is the fastest conversion time than the successive approximation, but circuit complexity is more in flash type compared to successive approximation. Thank you.